Hello, I'm Jeremy, and today I'm presenting Chapter 5, Section 3, Solving Multiple Angle Trigonomic Equations. One example of a real-life application of solving multiple angle trigonomic equations is if you were given a plot of the average weekly temperatures of a city and you were asked to find a curve which best fits that graph. Some important terms and techniques commonly used in this section include factoring GCFs, also known as greatest common factors, factoring patterns, isolating variable techniques, finding coterminal angles, and solving basic algebraic equations. First off, when you're solving these equations, you want to limit your values to 0, 2 pi, 0 to 2 pi. And if you were to graph 2 sine 3 of theta minus 1, this would be the graph you get. And where it crosses this x-axis are the solutions. And that's what we need to find. So the first thing we want to do when we're solving these equations is to isolate the sine 3 of theta. And you'll do that by adding 1 to both sides and then dividing both sides by 2 to get sine 3 theta equals 1/2. And the next thing we're going to do is forget about the 3 theta for a second and find the sine of 1/2. And the sine of 1/2 occurs at pi over 6 and 5 pi over 6. And then we'll rewrite it as 3 theta equals pi over 6 and 3 theta equals 5 pi over 6. And then we need to add 2 pi for the same amount of times as the coefficient of theta. So we'll add it 3 times. And 2 pi is the same as 12 pi over 6. So pi over 6 plus 12 pi over 6 equals 13 pi over 6. And then we'll add it again to get 25 pi over 6. And then we'll do the same thing down here to get 17 pi over 6 and 29 pi over 6. And then we will divide all these numbers by the coefficient of theta, which is 3 again. So we've got pi over 6, 13 pi over 6, and 25 pi over 6 divided by 3. And then we've got on the bottom 5 pi over 6, 17 pi over 6, and 29 pi over 6 divided by 3. And then when we divide it by 3 is the same as timesing by 1/3. And when we times this by 1/3, we're to get pi over 18. And then for this one, we will get 13. Camera shut off. As I was saying, for this one, we will get 13 pi over 18. And then for that one, we will get 25 pi over 18. And then for these ones down here, we will do it again and get 5 pi over 18, 17 pi over 18 and 29 pi over 18. And those are the 6 solutions we need. And now for this one, we're going to solve 4 secant 2 of theta plus 8 equals 0. And again, we're going to isolate the secant 2 theta. So we're going to minus 8, and then divide by 4 on both sides to get secant 2 of theta equals negative 2. And then it's hard to work with secant, so we're going to use the reciprocal, which is cosine. So cosine 2 of theta, and then we get the reciprocal of this side, which is negative 1/2. And then so we'll rewrite it again as 2 theta and 2 theta equals, so we can get ready to put our answers here. And then we'll have to find again where cosine of negative 1/2 is, and it falls over here at 2 pi over 3 and 4 pi over 3. And then we have to add 2 pi to both of these again. And up here we're going to get 8 pi over 3. And down here we're going to get 10 pi over 3. And then since the coefficient of theta is 2 this time, we divide this by 2, which is the same as timesing it by 1/2. And then we'll divide this one by 2. And up here we're going to get 2 pi over 6 and 8 pi over 6. Okay. And then down here we will get 4 pi over 6 and 10 pi over 6. And these are the solutions, but we can reduce them. So this will equal pi over 3 and 4 pi over 3. And this will equal 2 pi over 3, and this will equal 5 pi over 3. And these are the solutions.